Okay, so today we are going to talk about direct and inverse variation. Okay, in direct variation, it's very similar to like a linear function. Direct variation is a relationship that can be represented by a function in the form y equals kx, where k cannot be 0. Okay, the k is called the constant of variation for a direct variation. So we're going to use this equation every time we see that phrase direct variation, or it varies directly is what we normally see. And with this, sometimes they give us the k, sometimes they don't. Okay, so let's do some examples and I'll show you what I mean. So suppose that y varies directly with x. This right here is a very key phrase. It tells us what equation we're going to be using. So we're going to be using y equals kx. So there's two parts to this. The first part is we're going to write the direct variation equation, and then we're going to find the value of y when x is 12. Okay, so we're going to split this screen off here. So I have number 15. I have y is equal to -10 when x is equal to 2. These are kind of like coordinate points. X is 2, y is -10. And what we're going to do is we're going to plug in what we know and solve for that k. So I know y is equal to -10. I'm trying to find k, and I know x is equal to 2. So in order to get k by itself, I'm going to divide both sides by 2, and I get k is equal to -5. Okay, so that's an important feature. So the part A, the direct variation equation is going to be y is equal to -5x. I shouldn't have a k in here at all. Okay, guys, so when this is our equation, but again, we're writing an equation that helps us with this specific coordinate point. So then it says find the value of y when x is 12. So if x is 12, we're trying to find the value of y. We're going to use this equation to help us. So we don't know what y is equal to. We know k is -5. We know x is 12. So go ahead, we're going to put this, we can put it in our calculators or multiply it, whatever, and I get y is equal to -60. Okay, so this right here would be the second part of the problem. All right, so let's talk about this one over here. We're going to do it in the same exact way. So again, we're finding a new k value. So I'm plugging in what I know. I know y is 5, and I don't know what k is actually, and I know x is 2. So again, we're trying to get k by itself, so we're going to divide by 2. And over here, I'm going to get a decimal. That's okay. I like to leave decimals in fraction form. So it'd be k is equal to 5/2. So my equation is going to be y is equal to 5/2 x. That's my equation right there. Okay. So then we use this equation to find the value when x is equal to 12. So let's see, y is equal to 5/2 times 12. Okay, the 2 and the 12 cancel. So I get y is equal to is equal to 30. Okay, and those are the simple ones. It's not going to get really much harder than this, except for when we have some word problems. Okay, and this is a key feature with word problems. So right here it says the weight on Mars, y, varies directly with the weight on Earth. When we do these, you want to circle the word directly. Whatever comes before it is going to be the y. Whatever comes after it is going to be the x. So that means Mars is y and Earth is x. Okay, so we're going to write an equation that relates to the weight in pounds on Earth and the weight on comparing Mars and Earth. So we have some information over here. So again, we're writing the equation. So we're going to use our first equation, y is equal to kx. Again, y is the Mars weight, and the Mars weight is going to be 50 pounds. We don't know what k is, and Earth is 130 pounds. Okay, so again, we're going to divide by 130, and I get k is equal to, remember zeros cancel, 5 over 13. Okay, so that would be our k value. All this asked us was to write the equation. So the answer is actually going to be 5 over 13x. So what do we just solve for? So basically I can plug in a weight. So let's say, I don't know, my dog weighs 40 pounds. So I can plug in 40 for x. And I can solve this. And I can find that on Mars, my dogs would weigh about 15.4 pounds, which makes sense because there's less gravity on Mars. Okay, so let's also talk about inverse variation. Inverse variation, remember, the word inverse basically means you're going to do the opposite. Everything is exactly the same as before, except we just have a new equation. Okay. The only difference, though, is there's something that doesn't work in the denominator. Remember, you can never have 0 in the denominator. Okay, it makes it undefined. So inverse variation kind of has 2 equations, but we like to use the top one because the top one has y already by itself. Okay, so let's look at this one. So suppose y varies inversely with x. Again, that inversely tells me that I'm going to be using the equation y is equal to k over x. So again, I'm going to plug in what I know. I know y is 8. I know x is 3. And this one actually wants to know the equation. So once we find k, we'll be done. So there's a 3 in the denominator. So you're going to multiply both sides by 3. And I get k is equal to 24. So when I plug it in, 24 in for k, I get y is equal to 24 over x. And that would be my answer because they don't want any other information. Okay, so again, it's very, 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 very similar. We'll do one of these just to make sure we got it. Let's just do the first one. So again, that varies inversely tells me I'm using y is equal to k over x. Plug in what we know. We know y is 6. We know x is 3. I'm going to multiply both sides by 3. I get k is equal to 18. And again, this just wants the equation. So I get y is equal to 18 over x. And that would be how we do these. Okay. This one's a little bit different. So suppose y varies inversely with x, write an equation. Okay, so here, again, varies inversely, y is equal to k over x. So I get negative 8 is equal to k over negative 32. Okay, multiply by negative 32 to get it out of the denominator. And I get k is equal to 256. So my equation is going to be y is equal to 256 over x. That's the first part. That's part A. Part B wants to know what is x when y is equal to negative 4. So again, we're just going to plug in everything we know into the equation that we made. So I know y is equal to negative 4. I know k is 256. And I'm going to put it over an x. Now here, again, we're going to multiply, just keeping with that consistent pattern of multiplying by whatever's in the denominator. And I get negative 4x is equal to 256. I'm trying to get x by itself, so divide by negative 4. And I get x is equal to negative 64. Okay, So again, we're just trying to differentiate between the two and figure out how we figure everything out. So this is another problem you might see. Again, y varies inversely with x. I'm hoping you guys have noticed that y's always come first and the x's come second, okay? So what we're going to do is we're trying to find an x here. So we could use any one of these points to find what our k value is. So we get y is equal to k over x. Let's use 2 and 18 because it's the first one. Why not? So I get 18 is equal to k over 2. Again, I'm just grabbing these from that table. Multiply both sides by 2, and I get k is equal to 36. So now that I have my equation, y is equal to 36 over x, I'm going to go for what I'm missing here. So I am missing this m, which is an x value, and the y is 3. So I'm going to plug in 3 for y. Again, I'm multiplying both sides by x just to get it out of the denominator. So I get 3x is equal to 36. Divide both sides by 3, and I get x is equal to 12. So, well, it was an m, but that doesn't matter. So our missing value is going to be 12. Okay, let's talk about a couple more word problems here. So if x varies inversely with y and y is doubled, then what is x going to be? Okay, so the best thing that we could do is possibly just make up, and this actually has a typo in it, that should be a y and this should be an x, is kind of make up an example. So I'm going to say x is equal to 2, and we're going to see what's going to happen here. So let's say y is equal to 4. Okay, so then when we plug in what we know, we get y, remember this is inverse, k over x, so y is 4, k over 2, multiply both sides by 2. Again, I'm just picking random numbers, guys, okay? So k is equal to 8. So my equation would be y is equal to 8 over x. Okay, so what this says is what happens when y is doubled, okay? So y was 4. So when we double it, we're going to see what happens to the x, okay? So doubling it, my new y, let's get a little differentiation here. My new y is going to be 8. So if I do this here, I go 8 is equal to 8 over x. Multiply both sides by x, I get 8x is equal to 8. Divide by 8, I get x is equal to 1. Okay, so let's look and see what happens. So here my x was 2, and here my x is 1. So let's go ahead and look at our answer choices. So what happens when we doubled that y value? Well, it says, did x get multiplied by 2? That's not right. Decrease by 2, increase by 2. Actually, our answer is going to be it was divided by 2, okay? Because if you take 2, you divide it by 2, you get 1. Now, if we use different numbers for this, we would still have the same situation happening here, okay? Let's again talk about some word problems because the word problems are the ones that throw everybody off. Okay, so the width of the rectangle with a constant area varies inversely as its length. Notice they didn't say y varies inversely with x, but we need to know, okay? When you have varies inversely right here, circle it. Whatever comes first, which is the width, whatever's first, that's going to be your y value. So y is going to be the width. And then whatever comes after is the length. So if it's second, it's the x value. So the length is going to be the x value. Okay, so if the width is 4, when the length is 12, so again, y is equal to 4 when x is equal to 12, find the width. So find y, looks like a 2. So find y when x is equal to 6. Okay, so again, it's varies inversely, so we're going to use y is equal to k over x, and we just plug in everything we know. So 4 is equal to k over 12. Multiply both sides by 12, and we get k is equal to 48. So my equation is going to be y is equal to 48 over x. Plug in what we know. We don't know what y is. We know x is 6. So y is equal to 48 divided by 6. And then 48 divided by 16. I'm sorry, 16. So 48 divided by 16 is 3. So if the length is 16, that means that the width is going to be 3. Okay, so I'm not actually going to do this problem, but let's talk about what this is asking us for. So the diameter of the wheel varies inversely, again, varies inversely as the number of revolutions that the wheel is to cover a certain distance. Okay, so just talking about what x is and what y is. When you circle the inverse varies inversely, whatever's in front of that, so the diameter is going to be the y. And then whatever comes after revolutions, that's going to be our x value. Okay, so I'm not going to do this problem, but you have to be able to differentiate which one's y and which one's x by just reading the problem, because you can see this doesn't tell you which one's y and which one's x. Okay, so again, here's a band. They're getting paid $350 to pay at the county fair. Let A represent the amount each member receives. So A is the money each gets, and N is the members. Okay, it's an inverse variation relationship between A and N. Okay, so let's talk about this a little bit. Let's look at our answer choices. First of all, we should automatically eliminate D. Now, why are we going to eliminate D? Because D has addition in it, and we haven't done addition. This is simply multiplication and division. Okay, so let's talk about, not even looking at the rest of these answer choices, let's talk about what happens. So each year, a band is paid $350 to play at the county fair. So the A is the amount each of these people get, and the N is the members. So if you were dividing out this money evenly, what you would do is you would take the $350 and you would divide it by the number of members. So let's say there's 10 members in the band, you would divide it by 10. Each person would get $35. So this right here should be our equation, okay? But as you can tell in your answer choices, there's nothing here, okay? Your answer choices, they don't match here, all right? However, if we start moving things around, because as you can see, in B, the A and the N are on the same side, and in C, the A and the N are on the same side. So if I try to get this N over to the other side, what I'm going to do is I'm going to multiply. So these are going to cancel over on the right side, and I get A times N is equal to 350. Well, that looks familiar. That's actually answer choice letter C. So this one right here, again, we're using an inverse variation relationship. However, there's no multiplication, or there's no division here, so it can kind of trick people. Okay, so let's look at these special variations, and this is what would be on like final exams and things like this, because they always try to trick you. So we have the distance varies directly as the square of the time. Okay, so again, varies directly, y is equal to kx. So the distance is going to be the y value. The time is going to be the x value because it's after that varies directly. But here's the kicker right here. It says the square of time. Okay. So if I have y is equal to kx, the x is actually going to be squared. Okay. So that would be my new equation. So if, let's do it. So if the distance is 24 when the t is 3. So remember, distance is our y, so the distance is going to be 24, okay, and then the time is 3. Remember, that time is squared. So really we have 24 is equal to k times 9, because 3 times 3 is 9. All right, divide that out. This is going to simplify to 8 over 3 is equal to k. Okay, so our equation is going to be y is equal to 8 over 3 x squared. Don't forget the squared. Then find the value of the distance when the time is 6. So again, we're trying to find the y value. So 8 over 3, the time is 6. Okay, we can use some math here. So times 36. That is going to be 12. Well, you cannot see that. It's going to be 12. And so when we finish this up, we get y is equal to 96. Okay, now this one we don't have any solving to do. So p varies directly, again, varies directly, y is equal to kx as the square of v. And then inversely, so let's talk about this first. So p varies directly as the square of v. So p is the y value. We have k and then the square of v. Okay? And inversely as the r, well, the inversely comes after, so that would be the x. We know x, if we look at our equation, x is in the denominator, so the r would go into the denominator, and that would be our equation. Okay? So the only other thing you really need to know about this is what the graphs look like. So remember, direct variation is a straight line. Direct variation is very similar to something that you're constantly getting. A great example of this is if you work at an hourly wage job. The amount of hours that you work means you get more money. The less the amount of hours you work, the least amount of money you get. Okay? It's directly proportional. Okay? So, you know, it's very much like a linear function, y equals kx. Now, inverse variation is inversely, so it's like oppositely proportional. Y is equal to k over x. But remember, that x cannot be 0. Okay? So basically, it's saying that it's not going to touch when x is 0 or when y is 0 because it would make this whole function undefined. So that's what the graphs would look like for the inverse variation.